Okay, in this reaction below, they are asking you what has happened. So let's take a look. So for aluminium to become Al3 plus, our OS has increased from 0 to plus 3. So increase in OS means oxidation. For our silver, it has decreased from plus 1 to 0. So here our OS has decreased. So this would be reduction. So if we look at it, they say the aluminium atom is reduced. No. The silver ion is oxidized. Silver ion, no. Silver ion is being reduced. The reducing agent is aluminium. So how do you know what's the reducing agent? Reducing agent means it reduces others, itself oxidized. So let's look at which is the one that has been oxidized. So the one that has been oxidized is aluminium. So therefore, aluminium will be the reducing agent. So C is correct. Okay, while D is wrong because silver is being reduced, which means it is an oxidizing agent. Okay, so we look at this again one more time. Reducing agent is one that reduces others, itself oxidized. Therefore, it's aluminium. So answer is C. So question 7 says which substance is reduced? Okay, and then next, which substance acts as a reducing agent? So let's look at what is reduced first. So here to here, we can see a loss of oxygen, which means this has been reduced. Okay, then next, this one here, the next one, this to this has gained oxygen. So this has been oxidized. So first of all, we can write the first statement where iron 3 oxide. So why is it iron 3? Because some may write iron 2 based on the number 2 over here. So let's check why is it iron 3 if you want to know the name for it. So Fe 3 plus O2 minus. To balance it out, this and this, the shortcut is to bring it down, written it like that. So it gives you Fe2O3. Okay, so because for it to have a Fe2O3 formula, the charge has to be Fe3 plus and O2 minus. The other way to look at it is to balance the charges, I will need 2 Fe3 plus, 1 Fe, 2 Fe, and 3 O2 minus. O2 minus and O2 minus. Okay, which is where we get Fe2O3. So therefore, it is iron 3 oxide because the 3 stands for the 3 plus. Okay, of course you could write the chemical formula as well, Fe2O3, that is fine. So iron 3 oxide is reduced. Reason is because it loses oxygen to form iron. Next, now they ask you which substance acts as the reducing agent. So we go back to here where we say that if it is a reducing agent means it reduces others and itself being oxidized. So the question is which is the one being oxidized? So the one being oxidized over here is CO. So there is one carbon, one oxygen should be monoxide. So carbon monoxide is the reducing agent as it reduces iron 3 oxide to iron and itself being oxidized by gaining oxygen to form carbon dioxide. So you explain both parts where it reduces others and itself being oxidized. Next question, they ask you to use the periodic table to name this group 5 element. So if you look at the equation, you will find that the group 5 element is Bi. So if you refer to the periodic table, you will see it as bismuth. Okay, then let's take a look and see which is being oxidized, which is being reduced. So here, there is a loss of oxygen, which means that Bi2O3 is being reduced. Okay. And for carbon, if you look at the other way, carbon is being oxidized because it gains oxygen. So it gains oxygen. So carbon is being oxidized. It's asking you to find the reducing agent and explain a reason. So again, reducing agent means it is being oxidized. So the one that was being oxidized just now is your carbon. So we will say that carbon is the reducing agent. Why? Because it reduces others, which is reducing bismuth oxide to bismuth, and itself being oxidized by gaining oxygen to form carbon monoxide. Okay, so for this question, when we read the question, when we say magnesium metal, we write magnesium metal. Solution of lead 2 nitrate, we write that down. Crystals of lead, that means we write that down as well. Okay, and solution containing magnesium ions means there must be a solution form. So let's say we say that there is my magnesium metal. So my magnesium metal will be solid form. Lead 2 nitrate, lead is Pb2 plus, nitrate is NO3 minus, which means I need another NO3 minus to balance the charges off. So I'll write Pb bracket NO3 close bracket 2. And in this case, my state here is aqueous because it says solution. Lead crystal, so Pb solid. Solution containing magnesium ion. So if you look at this equation, what I have is my magnesium, which is more reactive than my lead, displacing my lead out, so I will get magnesium nitrate. So this solution is magnesium nitrate. Okay, so magnesium nitrate, and I need 2 nitrate to balance the charges. So I have Mg bracket NO3 close bracket 2 aqueous state. Okay, and what we do for our ionic equation is that everything that is aqueous, we have to split it up. So we have our magnesium solid that remains the same. Our lead will be Pb2 plus aqueous state. Our nitrate, because there's 2 of it, we put it in front, 2NO3 minus aqueous state. Lead solid remains. Magnesium, Mg2 plus aqueous. And our nitrate, 2NO3 minus aqueous. Okay, when we break it up into ions, we write the 2 in front of that ion because it's 2 groups of that polyatomic ion. So once you have done that, you take a look and see what is the same on the left and on the right. So this would be the same, so we cancel it out, and this would be the same, so we cancel it out. Therefore, we are left with magnesium solid plus your lead 2 ion and your lead solid plus your magnesium ion. So this is your ionic equation. So we transfer it down here to get your ionic equation. Okay, next one. So for the next part, it says to name an oxidizing agent. So oxidizing agent means it oxidizes others, itself being reduced, and provide a reason. So now let's take a look at this. So for magnesium to magnesium 2 plus, the oxidation state changes from 0 to +2. That means this is an increase in oxidation state. So magnesium is being oxidized. Okay, so I'll write here magnesium. So I know it's being oxidized because of an increase in oxidation state. How about lead? Lead from oxidation state of +2 becomes 0. So lead, this one here, is being reduced because my oxidation state decreased. So now our oxidizing agent is the one that is being reduced, which means lead lead-2 ion is the one that is being reduced. But do we call it lead-2 ion? So our initial substance with my lead-2 ion was lead-2 nitrate. So it is lead-2 nitrate that is being reduced. So how do I explain it? Lead-2 nitrate is the oxidizing agent, as it oxidizes others, right? Which is oxidizing magnesium. Okay, oxidation state of 0 to +2, and itself being reduced by a decrease in oxidation state from +2 to 0. So I explained this in oxidation state. So this question here says to explain the term redox with reference to this reaction. So redox means that oxidation and reduction takes place at the same time. So let's take a look and see what happened. So aluminium from oxidation state of +3 to 0. So oxidation state of +3 to 0 means it decreased. So my aluminium ion is reduced. Okay, and for my potassium, from 0 to +1 means that my potassium here is being oxidized. Okay, because the OS changes from a 0 to a +1, there is an increase. So now we can see that there is oxidation and there is reduction. Both of them taking place gives us redox. So how do we explain to it? Though it's 1 mark, we want to be very clear. So we say that a redox reaction is a chemical reaction which involves oxidation and reduction. Okay, so in this case, potassium is being oxidized, okay, because of the oxidation state increasing from 0 to +1, and aluminium is being reduced as its oxidation state decreases from +3 to 0. So please make sure you have a complete answer. So here what we see is we see carbon becoming carbon dioxide. That means from a C, it became CO2, which means it gained oxygen. So one way to describe is oxidation. Okay, another possible answer could be combustion as well, because it is one way of carbon gaining oxygen. Here, they want you to identify the oxidizing agent, which means oxidizes others, itself being reduced. And the reducing agent, meaning it reduces others, itself being oxidized. So let's take a look at this. So from CuO to Cu, this has lost oxygen, which means that CuO has been reduced. So if it has been reduced, it is my oxidizing agent. Okay, next, carbon to carbon dioxide. This has gained oxygen, which means that my carbon has been oxidized. So if it has been oxidized, itself being oxidized means it's a reducing agent. Okay, so when you fill up the blanks, oxidizing agent would be CuO, reducing agent would be C. If you like to name this CuO, so again, CuO, O would be 2 minus. So what would be Cu such that it can be a ratio of 1:1, CuO without any numbers? Cu has to be 2 plus. Okay, which means that the name will be copper 2 oxide. 2 meaning the charge of copper is 2 plus. So you can name it as well, saying that it's copper 2 oxide and reducing agent is carbon. So we can write it out as copper 2 oxide and carbon. Okay, so the next one, this is what we have. So let's take a look and see what happens. So for Fe, the OS increases from 0 to +2. Increase in OS. So my Fe is being oxidized. Okay, which means itself is oxidized, it reduces others. So this is a reducing agent. My copper plus 2 to 0, the OS decrease. So my copper here is being reduced. So means it is a oxidizing agent. In case you forget again, so we can take a look at this. If something is being reduced, in this case copper, it is an oxidizing agent. And if something is being oxidized, in this case iron, that means that is a reducing agent. Okay, because both comes together. So a reducing agent reduces others, it's self-oxidized, which is here, it's self-oxidized. An oxidizing agent oxidizes others, it's self-reduced, which is here, itself being reduced. So always write notes so that you don't get confused. So our oxidizing agent will now be Cu2+, and our reducing agent will be Fe. So if you want to be clear, if it's Cu2+, you should write copper 2 ion, very important. And Fe, you would write iron itself, or iron atom, or iron metal. Okay? Either one is fine because this is not an ion. But for ion, you have to write the word ion over there.